Okay, welcome everyone. Today we are going to be looking into test levels, test types, bugs, and defect lifecycle. Okay, so let's quickly go into the table of contents. Okay, so we're going to be talking about test level, test type, what a bug is, component of bugs, defect life cycles, defect priorities, defect severity, and then we'll take your question. Okay, so test level. Okay, software testing involves various levels of testing to ensure the quality and reliability of software products. Okay, so when you are testing a particular software or functionality, there are levels to the testing. Okay, so it's not just one test, and it's important that we as quality assurance engineers will understand this level of testing and who carry out each of these testing. Okay, so each testing level focus on different aspects of software and contribute to overall testing process. Okay, so the first one we'll have is the unit testing. Okay, so unit testing, as you know, so unit testing tests the individual components. We'll come into who does this, as you know. Okay, this is usually done by developers, unit testing. So when developers has actually written, their code, they've, written their code to, perform a particular functionality. Okay, so they write up this unit testing to test all the method and the individual components, okay, around their code. Okay, so the objective of unit testing is to verify the smaller units of code, okay, typically individual functions or method, to ensure that it works as intended. All right. So the developer code log, let's say, for example, the developer is, has written a code for a login functionality, and they have different method or they have functions that does different things. So they will write a code in form of a test to validate that those individual functions and methods are working as expected. Okay. So like I said before, the unit testing is done by developers. So not us, we the QAs would not do unit testing. Okay, so it's usually done by developers. So the next one is integration testing, which is to test the integrated components. Unlike the singular, method and the functions that unit testing does, integration testing we test integrated components. Okay, and the objective is to validate the interaction between integrated components or modules. Okay, so and what are the activities that were done around integration testing? It includes identifying interfaces between components and test their interactions. Okay, and will ensure that data flows correctly across different parts of the system. Okay, so for example, we want to combine the navigation to URL. So once you want to test a login functionality, for example, okay, you have to navigate to the URL of that environment. When you get to the home page, okay, you can click on, let's say, for example, Facebook, for example, where you must have navigated to the home page. Okay, you can see the login button. Okay, you can click on it, enter your URL, enter your password, okay, and click on submit, and that would be submitted. If it's a valid URL, valid email address, a valid username, a valid password, it will be submitted and it will work. If it's an invalid one, it won't be submitted. You will get an error message and it wouldn't work. So that is you doing an integration testing. Okay, so the integration testing is done by QAs, testers. Okay, so we have system testing as well. So system testing involves testing the entire system. Okay, so how is this being done? Okay, the objective is to evaluate the complete and integrated software product to ensure it meets a specified requirement. Let's say we have a requirement that has been specified, and you are testing, we have a requirement, it's been developed. Okay, we'll have different components that has been putting together. Okay, we'll have different functionalities as well. So you are testing the entire component, you are testing the entire system to ensure that they have met that requirement. And the activity is to test the entire system functionality, performance, and security. Okay, and this is like doing an end-to-end testing, and this is done by by testers, the QA engineers. So we do the system testing as well. Then the next one that we have, which is acceptance testing. Okay, so in acceptance testing, okay, we are testing to ensure that this is being accepted, okay, by the either the VAs or the actual stakeholders, basically, or the users, right? So we're testing that here. This is that the users would accept this particular functionality or this particular application. Okay, so and the objective is to confirm that the software meets the user's requirements. So we are testing it as though we are the user, or we are testing it in such a way, we are doing this testing to ensure that user. So most often than not, the QS does it, and sometimes you can get the PA doing it, or in some cases, depending on the organization, they would get the actual user to do this UAT testing. So it depends on the structure of the organization. Sometimes in most organizations, they can get a user acceptance tester who will test, who will be doing their UAT for them, user acceptance testing. Sometimes they can get actual users to do their testing. Okay, so the activity that is being carried out is being conducted by a user or a dedicated testing team. Okay, and this acceptance testing includes alpha testing. Okay, we'll have beta testing. We'll go into more of this. Okay, in our next class, we'll have user acceptance testing, which is UAT. Okay, so just to give you a brief intro of what acceptance testing is. Acceptance testing is a kind of testing that is being carried out within the organization by a dedicated testing team. So most organizations, if they have a testing team, they say, okay, we want to do an alpha testing, which is usually a first kind of testing that is being carried out around acceptance testing. So they can get a dedicated testing team. Sometimes they get the entire development team to do the testing. Okay, so we have beta testing. Beta testing is performed by a selected group of external users in a real-world environment. So some organization would, as I think there's a website now the organization usually does use for their beta testing, where they can stimulate real-world user. They also have some organization that does acceptance testing, beta testing for organizations as well. So that is why you have, when you go out there, in a not Upwork, some freelancing company that want to employ user, employ different people, different testers across the world, to do their testing. Sometimes they ask them to do this sort of beta testing for them, but know that beta testing is not done internally. It's being done by selected external users, okay, in a real world environment. So we'll have user acceptance testing, which is the final testing by the end user to ensure the software meets business requirements. Most often, in most organizations, depending on the structure again, you get the PO doing the user acceptance testing, okay, especially when this application is being built and is not being deployed, it hasn't gone live. It doesn't have a live environment. External users are not using it, so they get the PO to do the final user testing. Sometimes in most organizations, they have the BA to do it. But if it's an organization that have the internal development team, okay, and that organization is not a software development company, but they have developers, they have testers who test, application that is being used by the company. So they would always, ask the user, which is also, members of staff around the organization, to actually do the UAT testing, because they will be the actual user. Okay, so bear that in mind. And that's it for the level of testing. So we'll go into testing types, okay, or test types, right? So from what we have here, you can see we have functional testing, we have non-functional testing, we have compatibility testing, and we have security testing. Okay, so we will be looking into the objective of functional testing. Okay, what are the objective of functional testing? So the functional testing is to verify that software functions as expected and according to specification. Okay, as the name, functional, right? You are testing to ensure that the application functions as expected. Let's say, for example, you have a login, like I said, and when you are testing to make sure that the login functionality functions as expected, the registration functionality is functioning as expected. Yeah, so when you are testing that, let's say you're a user, you have come to the website and you want to register, you click on register button, the registration page, display, you have entered your username, you've entered your personal detail, you've clicked on register, and then you register successfully, the error message pop up. That is to say that the registration functionality is functioning as normal or as expected. That is you carrying out functional testing. Okay, so under functional testing, we have a subtype. Okay, we have the unit testing, which I've said before, involve testing individual units or components. We have integration testing. Under functional testing, you carry out integration testing. Under functional testing, like I said before, you are testing interaction between two integrated components of system. And under functional testing, we also have system testing and acceptance testing. Know that these subtypes are test levels that I mentioned. So these are the various test levels that were carried out under functional testing. Okay, so we'll go to the next one, which is the non-functional testing. Okay, and this non-functional testing is you assessing the non-functional aspects of a software. And this includes the likes of performance testing. So now you are not testing how the application functions, but you are testing the performance. Okay, you are not testing if user can actually register, but you are testing how the application behaves. Okay, when multiple users are using them. Okay, how the time it takes for a page to load. You are testing, how the time it takes, how the application actually behaves, basically, and not how it functions. Okay, testing the performance of it. Another one is usability testing under non-functional testing. Okay, so usability testing, you are testing to ensure that the software is user-friendly. Okay, that it's easier. Let's say, for example, in an e-commerce website, they have a product. We are testing how easier it is for users to actually, come into that website. Okay, search for product that they want to purchase and actually purchase them, pay for it. How easy it is. Okay. Then the next one we also have is the security testing. So security testing has to do with identifying vulnerabilities and ensuring that data are protected. Okay, so some of these security testing could be, penetration testing, it could be vulnerability scanning and all that. Okay, so most often than not in an organization will have pen testers actually doing this. Testers can also do it, but testers don't usually do, penetration testing. We'll have penetration testers, and of course, it's not something that is being done on a daily basis. And as a matter of fact, we have had so many organizations that can do an automated penetration testing, can spin up an automation penetration testing, scripts for company that you have running on your pipeline to check for vulnerabilities, scan for every, input fields, check your registration and all those things. Okay, so now the next one we have is reliability testing. Under non-functional testing, we have reliability testing, which to ensure that the software is stable and consistent. So you have seen sometimes, especially with the government website, well, sometimes when they have, they will announce a particular scheme, right? And once they've announced the dates for that scheme to go off. Let's say they said, okay, we're opening a new ministry, and we're employing people from all different career, okay, and different departments. That application will be open on so day. So what you usually get is on that particular day they say the application will open, you will notice a large influx of candidates trying to apply for that job. Okay, so sometimes at some point the application will break. User will no longer be able to log in. Users will no longer be able to access that website. Okay, and that is because it's not stable and it's not consistent. Okay, and I think I did mention performance testing, just to throw more light on it. Okay, for performance testing, you're also evaluating the responsiveness, like I said, how it responds. You also evaluate the stability and scalability of that particular web application or software. Okay, so the next one we'll have is compatibility testing. compatibility testing. So with compatibility testing, you want to ensure the software function correctly on different platforms, different browsers, and different devices. Okay, you are looking to ensure that the website. So I have seen some applications that will function well on an Edge browser, but wouldn't function well on when you access that website on a Chrome browser. Yes, some applications are built to only run on a particular browser. Okay, they will have desktop applications as well. So, but there are some applications that are built to run across all browsers, all devices, and all platforms. Okay, so when is that application, when you are testing that application and you are doing compatibility testing, you want to ensure that you've run all these web application or web software on different devices. You want to ensure that you've run it on a desktop device. You want to ensure that you've tested it on a tablet. You want to ensure that you've tested it on a MacBook, an Android tablet, a mobile Android device with different sizes, and so on. You want to ensure that you've run it across all browsers such as Chrome, Edge, Safari, and so on and so forth. And you also want to ensure that you've run it on different platforms. Okay. So a sub type of compatibility testing is browser compatibility testing. Like I mentioned, you are running it across different web browsers. Okay. So now going into security testing. Okay. Security testing is where you identify vulnerability and ensure data are protected. Okay, so the vulnerability subset of security testing is vulnerability scanning. I've mentioned that before. Okay, which can be an automated assessment. Okay, for a known vulnerability. So sometimes, you can assess to see if there is, a vulnerability. Okay, on a device or a software, basically. So when it comes to vulnerability, we have what we call zero-day vulnerability, okay, which is not a known vulnerability, and we also have a known vulnerability. Okay, so now the next one is penetration testing, like I said, where you carry out a stimulated real-world attack to identify weaknesses, okay, on your web application. Okay, so we have more type of testing which include okay, we'll have more types of testing, which include, like we've mentioned, functional testing, non-functional testing, unit testing, we'll have system testing, integration testing, we'll have end-to-end testing as well, acceptance testing, smoke testing, security testing, sanity testing, performance testing, regression testing. We'll have alpha testing, beta testing, black box testing, white box testing. So I'll just pick some that I haven't explained, and then we can talk about them. Example is the smoke testing. Okay, so smoke testing is a quick assessment to determine if software build is stable enough for further testing. So sometimes a developer has actually, completed his coding and he has deployed it to a testing environment to say, oh, okay, just quickly check if so and so thing is working. Okay, you just go on it and then you can say, okay, I'll click on this button. Yeah, this button takes me, to so page. Let's say when I click on registration page, it takes me to a registration. When I click on registration button, it takes me to a registration page. When I click on login page popped up. When I click on about us, it takes me to an about us page, and all those kind of quick testing that you can do. Okay, so those are kind of smoke testing. We'll have the black box testing. So the black box testing is assessing the software functionality without knowledge of the internal code or logic. So you are testing it, you're having to see the code that developers has written. Okay, you're just testing it based on the requirements, based on what has been given to you. Okay, you go on the front end side of things, on the user, the GUI, okay, the graphic user interface, and then you start testing it. You are not looking at the logic, you're not looking at the method, you're not looking at the functions that developers has actually done. Okay, so we have the white box testing as well. So we have the white box testing. So the white box testing is where you have access to the software internal code and logic and structure as well. Okay, and there's some type of this white box testing, like we mentioned before, unit testing and code review. So you know that most organizations, once a code is done, the developer would write his unit testing, and once the developer is done with unit testing, everything is passing, he will create a pull request. You create a pull request. Once a pull request is being made, another developer will go in to review the code. Okay, review the code. After reviewing the code, ensure that all the code has met, the standard coding practice. Ensure that all the logics are correct. Ensure there's no, code that is being commented out, or that it has followed all the rules, basically. So they will now have to approve that code request, the pull request, and then it can be merged into development, and then subsequently merged into test environment for testers to start testing, depending on their branching strategy. Okay. So next we'll be looking into what bug is, and so on. So what is a bug in software testing? Okay.
Sorry, I have a little question
Yes,
or an
please.
observation.
Yeah.
The the test I described now, the
Yeah.
last test you described, which test was that?
White box testing.
Okay,
So
white box.
yeah, this is it. White box testing. So I was saying that under white box testing, okay, which I've mentioned before, when you are doing this sort of testing, you have access to the internal code. You can see the source code, you can see the logic, you can see
Okay,
all the functions,
okay,
you can see the method, the structure of the code. So what developers
okay,
usually do is, and people that does this white box testing are developers. So they write logic to validate all this. They write a test, okay, to validate all their method, all the functions that they've written, and all their logics as well. Okay, and the kind of testing that they do here is known as unit testing. And under white box testing, we have what was called code review. And for code review, how it's been done is, once a developer has done, writing up a code or building a particular functionality, okay, so they will create a pull. They've written their unit testing, everything is passing. So they will create a pull request, a PR, pull request. So the essence of pull request is, once a developer is done writing up, developing a particular functionality, they don't just merge it to master and then merge it into testing environment for tester to start testing. Okay, that's not the standard practice. The standard practice is, once they are done developing, okay, they've done their unit testing, the unit testing is passing, so they will create a pull request. Okay, so that pull request is what enables code review. That's the last thing I mentioned, code review. So another developer, mostly a senior dev, okay, would come and look at their coding, their code, look at their method or the function that they've written, look at the logic, ensure that there's no commented out code, ensure that they followed all the rules. Okay, and after that, they can now approve that pull request. Once the pull request has been approved, it will be merged into the
okay,
appropriate environment for the next phase of testing, which will be the integration testing.
okay. I want to, so the black box testing, right?
Yeah.
The QA is not aware or doesn't have access to the code, right?
So yeah, yeah. The QA would not see the code. You don't have access to the code that the developers has written. All you can see is that whatever they've written has been deployed into your environment, and you can see it from the UI, from the front end, basically. You can navigate to the web application or the mobile application, and you can see whatever functionality they've developed. And then you are testing it according to the requirements. So you are not looking at the code, you are not looking at the logic that the developer has written, but you are just testing it from the front end based on what the requirements are stated. That is black box testing. Does that make sense?
Yeah, yes,
So
yes.
the only difference between them is, for black box testing, usually done by the QAs, they don't look at the code. They only look at the graphic user interface side of things. Okay, so they don't have access to the internal code. Whereas the white box testing, usually done by developers, they are testing the internal code. Okay, the internal source code. So those are the different.
Okay.
Yeah. So we're going to what a bug in software development is. Okay. So a bug in software testing, also known as a defect, we've touched this yeah, in our previous class. Okay. also known as a defect, which refers to an unexpected behavior in a software application that deviates from its what intended functionality. Let's say, for example, the requirement says that let me use a simple example. Let's say a logo, right? The requirement says that the logo will be at the top left-hand side of the website or web application. Okay, and the developer has done it and placed it at the top right-hand side. Okay, deploy it and you are testing it, and you find out that it's at the top right-hand side instead of the left-hand side. Okay, it's a defect. Okay, so you report that. Let's say, for example, another example, for a login functionality, you have to use a valid username and valid password, and you submit. You click on login before you can log in. And you've entered a valid username and an invalid password, and it still allows you to log in. It's a bug because it's not functioning as intended. It has deviated from its intended functionality. So that is what a bug is. Okay. So let's go to the next slide. So now, as a software tester, when you raise a bug, when you find a bug, you don't just say, oh, okay, I found a bug. You call the developer, oh, I found a bug. Can you go and fix it? No. When you find a bug, you raise the bug. Pay attention. This is a very important aspect of a tester. And recruiters don't joke with this question. They usually ask this question: what are the components of bugs? When you have found a bug, say you are testing a website, you found a bug, how do you report them? How do you report it? Okay, so now you report a bug with its components, and the components are as follows. The first one is title. Okay, so you will write a concise and descriptive title that summarizes the nature of the bug. Okay, so let's say, for example, the first instance that I gave us, which is the logo is on the right-hand side, top right-hand side, instead of on the left-hand side. You've raised that. So when you are filling the bug, you have to enter or write a concise title and descriptive title, which could go as, okay, the logo, okay, is at the top right-hand side, okay, or logo not found at the left-hand side, top left-hand side of the web page. Then you can now continue. So you have to give a descriptive. Let's say, for example, the one that I also mentioned, which is user logging in with invalid password. Okay, you can say user is able to log in with an invalid password, or user can log in with an invalid password. So that once they've read it, once they've looked at it, it gives them an idea of what the bug is saying. Okay, so the next we'll have is description. So once you have a bug, you put the title, you have to include the description. And the description is a detailed description of the bug, including what went wrong, the expected behavior, the actual observed behavior, provide steps to reproduce the issue, make it easier for developers to recreate the bug. So once you found that bug, you've entered the title, okay, you have to give a description. We usually call it a repro step or step to reproduce. You need to outline step by step, okay? You can say, giving a user navigate to URL, okay? When user click on the login button, okay, and user enter a valid username and an invalid password, okay, then user click on login, then user is able to log in. So that description is now telling the developer, once you follow this description, you've entered a valid username, you've entered an invalid password, and you are able to log in. It's not telling the developer. Once the developer has read it, the developer will already know that, oh, and I can see the title, and I can now see that this tester has used an invalid password and was able to log in. Okay, that is you giving a good description, a repro step that they can follow to reproduce the bug. Then you can go ahead to write the actual results and the expected result. You can say the expected result is when user should not be able to log in with an invalid password, but actual result is user is able to log in with an invalid password. Okay, so once they have gone that, they've seen, okay, this is the actual result, what you are observing. Actual result is what you are observing when you have gone to that application. And the expected result is what you are expected to see, of which one or that users shouldn't be able to log in with an invalid password. Right. So the next one is environment detail. So once you've entered the title, you've entered the description, including text to reproduce, expected and actual. You will now give environment detail. The environment where you are actually testing that web application. Okay, so your environment will be information about your environment in which the bug was observed, which includes your operating system. Okay, let's say you are testing that particular website on a mobile device, an Android mobile device. You say that it's an Android mobile device, which is a window laptop. You can say, okay, this is Windows 10. Okay, you give information about your operating system. Okay, if it's a Windows 10, if it's a Mac OS, okay, you mention it. You will give browser, if applicable. Let's say you are testing it on a Chrome browser, okay? And let's say, for example, that sometimes a bug you can find a bug when you are testing with a particular browser. So you have to give detail on the browser where the bug, where you're actually testing and that bug occur. Okay, you will give detail of your device as well, the model, if applicable. Sometimes it's not applicable, sometimes it is. Okay, so the next one that you need to mention is severity and priority. Okay, you have to state the severity and priority. Okay, the severity, which is the impact of the bug on the software functionality. It's usually categorized as critical. You have to mention if the severity is critical. You also have to mention if it is major, if it is minor, or if it's a cosmetic bug. Sometimes bug could be cosmetic. Sometimes you overlook it. So if the bug is cosmetic, let's say, for example, you have, let's say, font size, basically. Okay, let's say instead of using a H1, they went and used H2. Okay, and the font size is bigger than it should, or some of them are bigger than other. It's a cosmetic bug. Okay, that doesn't mean that the web application cannot go live. It can go live and then it can be fixed. Okay, it's not critical, it's just a cosmetic change. Sometimes it's a minor change. So with minor bugs, sometimes they can say, oh, okay, it will have a minor severity, it's not a showstopper. But once that bug is critical, it's a showstopper. That application cannot go live. It has to be fixed as soon as possible. So when you are raising a bug, that's why we all need to know this as QA. When you are in an organization and you're raising a bug that is critical, every dev will have to leave what they are doing and they will jump into it to make sure that it's fixed. If it's an application that hasn't gone live and you're about to do release and you find a bug that is critical, it will not go live. You will say, no, I'm not signing this up out. You put your feet down and say, this is not going live. This bug must be fixed before we go live. Okay, so we have priority as well. So the priority is the urgency with which a bug needs to be fixed, and it's categorized into high, medium, low. Okay, so if it's a low, if the priority is low, it wouldn't be picked up. It could most often in an agile they will say, oh, okay, we are busy with more critical and more higher priority bugs or higher priority functionality. We can put this at the backlog and handle it in our next sprint when the priority is low. Okay, when the priority is high, of course, they would want to prioritize it and start working on it or start fixing the bug as quick as possible. All right, so the next one we have is expected and actual result. I think I've captured that under description, where you have to put your expected and actual result, okay, which is where you put a clearly articulated of the expected outcome, of what the expected outcome should be, okay, and describe the actual result observed. This helps in highlighting the deviation from the expected. So once they've looked at, sometimes I get loads of bugs, raised by the stakeholders, or fellow colleagues. They will say, "Oh, okay, can you try to replicate that?" So sometimes when you are going, especially with a software that you are not quite familiar, you are not conversant with how the functionality, how it functions. Okay, so when you do not have the expected and the actual, you can follow the repro step follow the description and everything, but you still don't know. Yes, you are getting that they say this is what it should happen, but sometimes you still don't know what the expected should be, right? So you get confused if actually it's actually a bug or not. But when you have the actual and the expected, you can say, okay, this is what I'm expected, and okay, this is what I'm getting. That's the importance of having the actual and the expected. Okay, so we can now go to the next one, which is attachments. Okay, so like I said before in our previous class, we as a QA, you have to take notes, take a record, video record, screenshot of whatever you are doing. Okay, so when you are testing an application, you found a bug. Okay, you've raised it, you've added all the components, you've added the title, the description, the environment details, you've included the severity and priority, you've added the expected and actual result. The next thing you have to add is a screenshot. Okay, you need to include any relevant files, screenshots, or even video that illustrate the bug or its impact. Attachments can significantly aid developers in understanding and addressing the issue. So sometimes, even with the description, they might still not be able to replicate that bug. Okay, but when you have a screenshot, a video recording of that application or of the bug, okay, they will play it. Oh, okay, I've seen it. Then it helps them to replicate it and get it fixed. Okay, so creating a comprehensive and a well-documented bug report is crucial for effective bug tracking and resolution. Okay, clear and detailed bug reporting facilitates effective communication between testing and development team, ultimately leading to faster bug resolution and improved software quality. Okay, so don't worry. All these that I'm saying, this bug component, you start writing your test case, you start, executing your test, you start picking loads of bugs, and you start reporting them. When you are reporting them, you need to ensure that all these 6 components are on any bug ticket that you're raising. The title, the description, the environment details, severity, expected and actual results, and attachments. All right, so let's go to the next slide. So now we'll go into defect life cycle. Defect life cycle. Okay, so defect life cycle. Defect life cycle in software development. Okay, so defect life cycle is, I can see defect life cycle SDLC in software development life cycle is a systematic. So note that, yeah, defect life cycle is not SDLC. SDLC is software development life cycle. So this is just defect life cycle and not SDLC. Okay, so defect life cycle is a systematic process that describes the stages of is the stages that a defect goes through from identification to resolution within a software development and testing team. Okay, so when you raise a bug or a defect, it goes through a process. You don't just raise a bug. Once you've raised that bug, everything is all okay. You forget about the bug. As a tester, you also track the bugs that you've raised. You also ensure that it gets fixed. You also ensure that you track it. You also ensure that it gets fixed. You also ensure that you tested it and you close it. So you have to follow it up. You need to understand the process that every defect goes through. Okay, so this defect lifecycle helps to manage and track defects effectively, ensuring they are addressed in a structured manner. Okay, and okay, you can see on the slide, defect lifecycle is also known as bug lifecycle. So don't get it twisted. Defect lifecycle and bug lifecycle are the same. Okay, so now let's go through defect lifecycle in detail and how and the defect lifecycle states. Okay, so let me take it this way. So in a defect lifecycle, okay, we'll have the first stage, which is new. We'll have the second stage that is open. We'll have the third stage assigned. We'll have fixed, retested, reopened, closed, duplicate, rejected. So defect lifecycle can assume any, Different life cycle states can be in any of these states, depending on the situation around that defect. Okay, we'll go through a flow chart to show you how all these things flows. But first, we need to understand what all these states mean. We want to understand what new means. We want to understand what we want to understand what new mean. We want to understand what open means. We want to understand what assigned means. So for a new state, a defect has been raised and logged. Okay, let me take it again. When you are testing a web application and you've seen a bug and you've raised it, including all the bug components, okay, all the six bug component that was stated, it assumed a status of a state or status of new because it's just a new bug that you've raised. Okay, so now it goes into a different state, which is open. Okay, and the open state means that the defect is acknowledged and accepted by the development team for resolution. So once you've raised that bug and they say, oh, okay, yes, we've accepted this as a bug, okay, it becomes open. Then the next one is assigned. A member of the development team has been assigned a defect. So they say, okay, let's assign this defect to, okay, developer A, we're assigning the defect to you. So the status of the defect changed to what? Assign. So we have fixed. The developer submits the modified code to the testing environment, and the testing team is notified that the defect is ready for verification. So once the bug has been fixed, has been worked on by a developer, okay, and feel that yeah, he's done, he has deployed that particular fixed code, okay, into the testing environment, they will change the status to fixed. Okay, now the tester will now say, okay, let me go and retest it to find out if the bug is fixed. Okay, that is when it assigns the state of retest. Testers execute the test cases related to the fixed defect to ensure that the software issue is indeed resolved. Okay, so if it's resolved, it goes to close. But if it's not resolved, okay, it's reopened. It will be reopened. So the defect. So if the defect is not necessarily resolved, or if new issues are identified, it is reopened and the cycle returns to the assigned or open states. So at this point, the tester will go and test this particular functionality, check if everything is fine. If it's not fine, they'll reopen it. But if it's been resolved, okay, it will be closed. So we have what is called a duplicate state as well. So the duplicate state is if the defects, if it is determined that the reported defect is a duplicate or an existing one. Let's say, for example, you've raised a bug and another tester has raised the same bug, okay, and it will have two bugs. So it's not a duplicate, okay. It would be given a state of what? Duplicate. Most often, that duplicate is usually deleted, okay, or closed. So we have rejected. If a defect has been raised, okay, and it's not able to be reproduced, you've raised a bug, the development team or someone else has picked it up, the person is not able to reproduce it, the bug is no longer there, okay, it will be rejected. So that is the state of rejected. Okay, so now let's look at how it flows. Okay, so and I will explain this with the same analogy that we'll be using, okay, which is you are testing a login functionality, for example. Okay, you've entered the username and you've entered your password, you've entered a valid username and you've entered an invalid password, and you click on submit and it's submitted. Okay, that means it's a bug. You've raised them, including all the 6 components of bugs. Okay, once you've raised them, once you've raised the bug, you've logged all the 6 components, you've entered the title, the description, the expected and actual result, the priority, the severity, you've put in a screenshot. Okay, once you've raised that, you will have a status change to new. Okay, so that is what you have new here. So once it's been changed to new and it's been accepted as a bug, okay, it changed its status to what? Open. Okay, so now the status changed to open. Once it has been changed to open, okay, we will not have to look into it. So once it's open, someone will go and look at it and say, okay, is this a duplicate bug? If it's a duplicate bug, it gets deleted, the life cycle ends. If it's a duplicate bug, it gets what? Deleted or rejected, or it gets deferred. Okay. Oh, no. So what I'm trying to say is if it's a, once it's open, okay, we'll check if it's a duplicate. If it's a duplicate bug, it will be deleted. One of it will be deleted. Okay. If it's not a duplicate bug, we'll check if we're able to reproduce it. If we're able to reproduce it and we're not able to reproduce it, what happened? It will be rejected. Okay. If we have looked at it, and I'm trying to explain the defect now. If we looked at it, it's a cosmetic bug, it's not urgent. What we'll do is it will be deferred, possibly to the next sprint. Okay, so but if it's actually a bug, it has higher priority, we want to fix it within the sprint, what we'll do is it will be assigned to a developer. Okay, once it's been assigned to a developer, it will be, the developer will work on it. And once the developer is done working on it and fix it, the status will change to fix. Okay. Once it's been fixed, it will be deployed to a tested environment where the tester will go and retest it. So once the tester has retested it and run regression testing around, each component and everything is okay, it will be verified and closed. But if the developer is testing it and have found, if the tester is testing it has found that the issue is not fixed, it will be reopened, go back to assign, and then fix, the developer work on it again, fix, retest. If the issue is not resolved, reopen again. If the issue is resolved, verify and close. All right. So that is the life cycle of a bug. That's its life cycle. Yeah, sorry for that break. Okay, so the next one is the deferred priorities. Okay, so I briefly mentioned about the deferred priorities in the last previous slide. So, but let's look at it in depth. Okay, deferred priority. So, yeah, so deferred priority, okay, which is referred to the level of importance or urgency assigned to a reported defect within the software and testing process. Okay, like I said before, so the priority is, well, how important or how urgent it is. Okay, so like I was saying that if the priority could be low, okay, the priority could be it could be low, it could be high, and then it could be minimal, or it could be critical. Okay, so prioritizing defects helps the development team and testing team to focus on their efforts on addressing the most critical issue first. So let's say, for example, we'll have that cosmetic, bug, and we'll have a bug that, wouldn't allow, users to pay for a product they've purchased. Of course, the one that, wouldn't allow them to pay for a product they purchased will be the higher priority and will be prioritized first. Okay, so we'll have, like I said, we'll have the different priority are classified into low priority, medium priority, high priority, and what critical priority. So low priority has minimal impact on the system functionality and can be delayed until most important fixes are completed. So let's say you've raised a bug, for example, that is not of a higher priority. It could be moved or deferred to the next sprint. Okay, so let's say, for example, even in an organization working in agile, when they have all the functionalities to fix all the stories, so it will be prioritized according to, if it's critical, if it is high, if it is medium. So most often developers start developing on the most critical, defect or the most critical functionality. So that's why I also advise us that if you are in an organization, stories has been committed, look at the priority, okay, and start writing your test case from the ones with most critical or high priority. Right. So medium priority defects have noticeable impact on the system and should be fixed in subsequent build. Okay. So, and the medium priority issues, okay, could be a secondary feature or a non-essential functionality. Okay. It could be that the application is performance has degraded a little bit. Not that it's not performing as expected, but the performance has degraded a little bit or have a moderate degradation. It's not working as expected, but it's not a showstopper, basically. So you can say, okay, let's push out this fix, and then in our next fix we can fix it. Okay, so we'll have higher priority. Higher priority defects have a significant impact on the system. Okay, for example, in a mobile banking application, a higher priority defect is identified when user cannot transfer funds between the accounts. Okay, while the rest of the app functions, the inability to perform a crucial transaction makes the defect a higher priority for immediate resolution. Right, so we can now go over to the critical. The critical defects have a severe impact on the system. It rendered the software or the application unusable or causing a complex failure. Let's say, for example, now an e-commerce website, okay, a critical defect is where users are unable to complete checkout. Okay, upon clicking on checkout button, the system crashes, preventing any successful transaction. This defect is labeled as critical. Okay, and it could be catastrophic. It could have a catastrophic impact on the core functionality of the application, which is basically user being able to being unable to pay or check out, so which of course the company will start losing a lot of money, and that needs to be fixed as soon as possible. So we have defect severity. Defect severity refers to the degree of impact a defect has on the system functionality or overall user experience. Okay, the severity level helps prioritize the resolution of the defect based on their potential impact. Okay, now let us explore each level of defect severity in great detail. So one, we'll have low severity. Okay, so we have low severity, and low severity, just like low priority, has minimal impact on the system and may include cosmetic issue or minor inconvenience. Like I said before, it could be just like a font size, or font color, or any of those. Okay, just something that is cosmetic, it's not causing any inconveniences. Okay, so the next one we'll have is medium severity, which is a moderate severity defect that have a noticeable impact on the system, but is not critical. Okay, they may cause inconveniences, but do not hinder essential functionality. As simple as that, just like medium priority as well. So we have higher severity, and the higher or major severity defects, okay, significantly impact the system functionality, but do not render it completely unusable. Okay, like for example, let's take that e-commerce for example. An e-commerce website experiencing a major defect where users are unable to add items to their carts. Okay, while the website remains functional, the higher severity defect affects a crucial aspect of the user experience and may result in revenue loss. Okay, so then we'll also have critical, which of course the critical defect has a severe impact causing the system, just like a critical priority, has a severe impact causing the system unusable. So example again I would take an example which is similar to that of a higher priority, which is a mobile banking app as well. Okay, when the application crashed completely and you are not able to transfer funds or even log in, for example. So that is it about the criticality. Okay, so any question?